Welcome to the first video in a beginner tutorial series where I cover how to design parts in Fusion 360 used for model rocketry. In this first video, I'll cover the basics of navigating around Fusion 360 by replicating the model fin can as shown below. So this was originally made in SolidWorks and then imported into Fusion 360. There's lots of value in covering assembly from scratch, because this requires a lot of tools beyond extrude and revolve. I'll also include my keystrokes to show the use of hotkeys, which greatly speed up the CAD process, and I highly encourage everyone to learn it. So this fin can has detachable fins with a dovetail slot, and at the rear these M4 bolts hold the fin can. The fin tabs also exist in the model, but we won't be modeling them. This is not a recommendation to build rocket fin cans this way. This is just a CAD piece used for education. So deconstructing a part can be like a detective game, and if you want to follow along with the challenge, you can also download the step file in the link in the video description below. So if you want to upload this to your own files, press File, Upload, and select Files, and you can click on the step file. I've already done that, so I won't be doing that again. So I believe that it's better to model the main part first, followed by the fins. So what are we seeing from this feature here? So there's going to be mostly the same cross-section throughout, so majority of this will come from an extrude, except from parts at the bottom, as seen here, and as well as this top surface, which is a revolve cut all the way around the top, but it also needs to fit this shape of the fins. So how are we going to do that? So one of the things I'm going to do is first open up a new design, and this is where we create our new part. I'm going to click on hybrid design, which allows internal components and external components. This is basically the best of both worlds for part and assembly design, which is the traditional way, like in SolidWorks. I just recommend to use the hybrid design. If I create new, the top level is going to be here, and I can create a new component by pressing this and fin can, name the part, and I can toggle between the component versus the top level assembly just by clicking the dot next to it. So the first step of detective work is to tell how the part was made and what the dimensions are. So by looking at the part, I think that the part was created first with a hollow cylinder, that being the inner diameter and this being the outer diameter. Then this quadrant was made, and then the extrude cut. So I'm going to create a sketch in this reference part just so that I can get the measurements. Press the vertex and the diameter on the edge on the bottom right. You can also press I, and that brings up the measurement tool, which will tell you more info. Finally, you can press P, which is the project tool, to select the vertex, and that will project whatever line onto the plane with which you're drawing. With that, you can press D for dimension and create a driven dimension, so that will tell you exactly what it is. I'm going to do that for the outer edge as well. It's the 55. I'm going to draw two circles based on that. In fact, I'm not going to need to draw a circle for the inner one because the project tool already creates a line. For this line here, I've selected it, but it says on the length 32.283. doesn't give the radius. That's because if I look at it in 3D, it's not a planar measurement. If I was to click down here, it would give the radius, or if I was to click the surface. To get this curve, I can also use the project tool again, and that will generate a circle with which I can make coincident to both lines. There are lots of ways to do this, of course, and what this diameter is 100, so I will define this as 100. In fact, it's a radius, so it needs to be 200. For this top curve here, I'm going to draw a circle and then try to approximate it as best as I can. So I'm going to move that here, and it turns out that this looks pretty accurate. So this circle is then defined by 55 millimeters above the midpoint and with a diameter of about 32.5. That's quite close. So with all of these, we can go back to the part and start making the quadrants. I'm going to begin with the two circles. Once again, this is 101.5, and the outer one I can do 55 multiplied by 2 to save me from doing maths. Then I can draw in fact I can probably use my arc tool, which is more suitable, and I can define that to be 100 and move the center point far away, and then define this point to be coincident and this curve being tangent. Next, I'll make that midline arc. And this is vertical constraint over the middle, so 16.3. And these two edges are coincident and tangent as well. I'm going to do one more arc on the left side. As you can see here, it's automatically entered the tangent constraint, but always be aware what constraints are automatically being applied because you don't want to get caught out. And the final dimension to define this is distance of 55, which is fine. You can press trim, T for trim, and cut that out for the correct shape. This dimension isn't defined yet, so we can actually set these two, select these two equal, and that will set it correct. Now I will proceed to use the rectangular pattern. In fact, before I do that, I'm just going to take another look at the part, and yes, this surface is in fact flat, with the bottom length being distance of 12 millimeters. So the one other thing I needed to do is to go here, define this as 12, and then take the trim off of the top part. It's destroyed some constraints, but that's okay. We can create the constraints again. We can create the line to here. I'm going to click this line, press X to make it a center line, and that will make it vertical, and that is all constrained. I'm going to use the circular pattern to select these objects, 1, 2, 3, 4, 5, around the center point. I want 4 of them, and then I'm going to press tick. I'm going to need to trim the rest of these. Even though I've trimmed those lines, everything's still white, so it says it's fully constrained still. I'm going to finish sketch, find the dimension of my extrude. I'm going to go back into the part and I'm going to select this line and shift select this line, and the bottom right tells me the minimum distance between these two lines is 200, and so that's going to be my extrude. So E for extrude, and then 200. So going back to our reference part, you can check out how the extrude cut was done on this profile. So what it looks like is that there is a trapezium shape that was cut out, and then those are simply just fillets. So you can go back into the sketch and look for the dimensions. So if it's a trapezium, we only really need to know the angle and the height of the trapezium, and we already know this width here being 12. I'm going to project this line, and then I will proceed to just extend these out a little bit such that I can get rid of the effects of the fillets I'm measuring. I'm going to make that parallel. And then finally for the dimensions, I can select this. So it turns out this is 8 and the angle is 60. So that's all we need. And we already know that this point is 55 mil from the center. The distance from the bottom to the bottom of the slot is 6 millimeters. So I'm going to leave an offset of 6 for when I extrude. Returning to this, I'm going to create a sketch on the top plane here, and I'm going to create my trapezium. That's a very nice constraint, and then we can figure out the size of all of the fillets. So if I click on this, radius 2, and then if I click on this, it's also radius 2. Easy. Good, and I'm going to extrude cut this all the way down, and I'm going to direction one side, and then extend type I'm going to change to object, and I'm going to choose to this face and having an offset of 6 millimeters, and I can see that it needs to be negative 6 millimeters. Tick, and good. That's exactly what we wanted. I'm going to press F for fillet and then set this to 5. It's not exactly the same, but it's good enough. And then we can use the pattern tool to repeat the same feature many times over. I'm going to select features, selecting the extrude and the fillet. I'm going to, for the axis, open up the origins tab and then select the Z axis. Quantity of 4, and I'm going to press tick, and that's all computed nicely. So if we want to do the revolve cut, let's first define a sketch. I'm going to use the project tool on the top line here and define the triangle as so. I'm going to press tick, click revolve, profile selected, and for the axis I'm going to select the Z axis and press tick, and that looks good. So for now, that is our center fin can, and at this point I recommend you save the file. I'm going to call this fin can replica, save, and now we can move on to the fins. So to toggle back into the assembly mode, you can click this circle, and of course nothing looks any different because we've only got one part. You can right click, press new component, and then parent from parent, which is the whole assembly, press tick, and now we're in component 2. I'm going to name this fin, and with this shadowy figure we can't affect it, but we can use dimensions from it. So what we can do is, given how this is constructed, I'm going to create the base of this with extrude and then the rest of this with a loft. So I'm going to start a sketch on this surface here, and rather conveniently I can also use the project tool again to obtain what I need from these. Tick, close off the surface, and I have this. I'm going to extrude this upwards all the way to the top of 200. Actually, it's going to be 200 minus 6, so let's do 194. Doesn't matter in the end too much because it's going to get cut. Now I'm going to pull the fillet on the bottom to correspond with the same fillet that's on the inner there, so I can do 5.15. So since this surface is flat, this will be one of my first faces to use the loft. I'm going to create the sketch here. And going back to the profile, essentially it's close enough to a circle on top and the rectangle stretching all the way to the bottom. So I'm going to use a midpoint line at the origin point and define this as 12. And I'm going to draw a line all the way up and all the way down. Let's make this vertical. And let's create a circle that's tangent to both of these. I'm going to trim the bottom half away and make this tangent. I would like the top of this to be tangent with this line, with this curve rather. So I'm going to project it, geometry, line. Good. And though I'm shift selecting both of them, for some reason the constraints are unavailable for tangent, so I'm going to just do a workaround where I'm going to just do something like this. I'm going to set that horizontal, make this coincident, and have a line that goes from here to here, being vertical. And I'm going to make all of these center lines instead of solid lines, and I'll make this tangent. And that's good because it's fully defined. I'm going to press tick. Now for the second surface, there needs to be a particular offset plane for which I can draw the second profile on. So the distance for that is going to be from this to this, which is 90.62. So I'm going to do just that. Construct here, 90.62. And this is the plane on which I'm going to draw my other sketch. Able to go into the loft tool, where I can select the surface, all of it, and the profile too. So that's all very good. And the loft tool has this circle here, which is sort of related to where it is lofting from. So I'm just going to drag that to the middle and drag this also to the middle. And I'm going to keep. This essentially just gives a very nice smooth line. Apparently not. Is that good? Yeah, that's good. Yeah, I'm not really sure what's up with that loft. I guess don't play around with the loft inputs too much. So the next thing we'll do is to do the holes. So there's going to be a hole that runs through both the fin and the fin can, as well as this portion here, which is the fin can only. We're going to do the sketch here, the surface, and as I've measured earlier, the center of this hole is 26 up and 63 side, so I'm going to quickly do that. This is an M4 hole, and so this is going to be 63 to the side, and it was 26 to the up. I'm going to cut extrude, and in this particular case, it's going to cut through both of them. I'm going to open the drop down and it says clearly that it can cut both of them, which is fine. Okay, for the next part, this little cut section here is specifically for the fin cans, so I'm going to go into the center fin can, and I'm going to make an offset from the center. So this is offset from the center of 10 millimeters. In this sketch, I'm going to use the same hole, and I'm going to emulate this teardrop shape. The reason for this is for 3D printing, so it helps with alleviating the overhangs. So we're just going to quickly do that. Set this to be tangent, and I'm going to set perpendicular to here. I'm going to set the project to give me a circle. I can make my circle coincident too. So I'm going to make that coincident. I'm going to define this. Well, first I'm going to trim, and then I'm going to define. This is 5, and then I'm going to make sure that the top of this is vertical. That fully confines it, and that looks good. I'm going to cut this, and that cuts perfectly fine. I'm going to mirror this across onto the other side. So mirror, and mirror the features, and the plane being this one. Now what we can actually do is to use the circular pattern and apply the components to everything here. So axes, do here, I'm going to press tick, and it's also possible to apply, going back to the fin can here, it's possible to apply a circular pattern to all of the features that were just done again. So features, features, and axis being the z-axis. So we all know that that works. For now, I'm going to just suppress those. I'm going to suppress features. So what we're going to do now is to insert a nut and a bolt. So under Insert, go to Insert Mastercard Component, and under this menu, you have components for virtually every single type of screws, bolts, nuts that you would ever need. what we want to look for is screws and bolts. We want a socket head screw. We're using metric, and we want an M4 bolt. And we want to find this length of 25. We'd like fully threaded, and under these options it gives you what CAD files they have. So under this blue link, you can click this, and download now gives you the part to insert directly in. So under the drop down you've got different options. You've got 3D step no threads. For now we're going to import in 3D step, which is going to include the CAD of the whole part with the threads. In the future for FEA I would recommend importing in no threads, because having the thread is for visual demonstrations but complicates the geometry during meshing. I'm going to click download, and that will bring the component in after a few seconds. There we go. So I'm just going to move that a little bit. And we're going to move this around as if it was an assembly. So I'm going to press J for joints, and I want this surface to match up with this surface, but also I want the centers to match up. And it's possible to do this in one go. So you essentially need to select the cross that it's in the middle there, but it disappears if you try to hover over it. So you need to hold Control, and then that allows you to move the cursor to press it. Then you need to go on to the other surface, and likewise hold Control, click that, and in just 2 clicks you've got the joint created. Next, insert the nuts. So we're going to again insert McMaster car component. Under nuts, we're going to go under lock nuts, because we always want nylock insert. So we're going to search metric again. We want M4, and high strength steel is a very regular sort of lock nut. So we're going to once again go in 3D step. I'm going to click download. That's going to bring in the component. Press tick. I'm going to zoom in, J, and that's the back, and that's going to be the front. And we're just going to put that there. Good. So now to bring the whole CAD back, we're going to unsuppress the features of these, and if we really want, we can also do a circular pattern on the components that we've just created. So we can do that for the nuts and bolts around the axis here. 4 copies, tick. And that's essentially the part complete. So one final thing we can do is to add material. Under Modify, find Physical Material, and we can scroll down to the plastic section. There's no specific option for PLA plastic, so we're just going to use some generic plastic like ABS, and click and drop to add the material. Close. That sets the mass and sets up the CAD for an FEA simulation. Thank you for watching to the end, and see you next video.